In this video, we'll be answering this question. We have a region bounded by two curves. We have x squared minus 10x plus 25 equals y, and we have x equals y squared. So one is a sideways parabola, one is a regular parabola. We want to find the area of this region. We're first asked to figure out whether we should use horizontal or vertical slicing. We are asked more specifically how many integrals will we get in each case, and then I'm asked to set up the area of an integral for the area of R, whichever way I want. Alright, so let's start with 1. So in my previous video, I mentioned that if the curves were given like this, as y equals f of x, you should use vertical slices. If it's given as x equals a function of y, you should use horizontal. Here we have a mixture of the two. That means that that clue doesn't tell you. From this, it could go either way. So I'm going to start looking at how many integrals I would need in each case. So let's say I'm using vertical slicing. The blue curve is fine. It's already as y equals a function of x, so I don't have to isolate. In the second case, I have to isolate y. So if x equals y squared, that means y equals plus root of x, or y equals minus root of x. So in this case, I would get two different functions. Let's use red for one and green for the other. So which one's which? These would have positive y, so this one would be y equals root of x. And you know that graph, it's one of the standard ones. This one is y equals minus root of x. Notice that our region doesn't touch the red curve, and that's good. That means we can use only this formula, and that'd be fine. And for the entire region, I would get top is y equals root of x, and bottom is y equals x squared minus 10x plus 25. I have one formula for top the entire time. I have one formula for bottom the entire time. That means I would need one integral. Alright, so it looks pretty good. In fact, at this point, I could probably just write out the area without the integral for the area without looking at horizontal because this works so well. But let's do it with horizontal also. Alright, so same region, but now with horizontal slicing, I need to solve for x. I need to isolate x. So in one case, that's already done, so let's put that one on the board. The green curve from the start was x equals y squared, so that setup is perfect for horizontal slicing, but the blue curve isn't. The blue curve is given to us as y equals a function of x. to be able to isolate x here, I need to complete the square. Well, in this case, it's not so bad, because what I do have is a perfect squared, so I get x minus 5 squared. And so x minus 5 is plus or minus root of y, which means that x is 5 plus root of y, or x is 5 minus root of y. All right, 5 is right here, so this is 5. 5 plus root of y would be bigger than 5, so that'd be here. Five minus root of y. Let me use red. Five minus root of y would be the second part of the parabola. Now, when I draw my horizontal slicing here, something's going to happen to left. For small values of y, left will land on the red curve. For big values of y, left would land on the green. So in this case, left would be red. But also green. Right, so left changes halfway, but right is always x equals 5 plus root of y. So to be able to write the area as an integral, I'd have to split that integral up at this junction that we didn't solve for. And so in this case, I would need two integrals. So which one should I choose? Vertical slicing or horizontal slicing if I see a problem like this? Well, personally, I see two reasons to pick vertical slicing. First one, this algebra here of solving for y is much easier than this one for solving for x. So that's one reason. Second reason, in this case, I get a single integral to compute. In this case, I get two integrals. So I would definitely use vertical slicing. That's my winner here. All right, in the second part of this, we're asked to actually give a formula for the area. Let me erase the horizontal slicing board, even though that's the last one I touched, because that's the one we'll use to actually solve the second part. So now we want an integral for the area. We're told to use, well, we've decided to use vertical slicing. So it's going to be the integral from a to b, top minus bottom dx. Now we're told in the actual question that you have on your sheet to just assume this point is AC and this point is BD. So this is A, this is B, without actually solving for it. The algebra is not nice and numbers are not nice. And so A and B, so I'll get the integral from A to B. Top we said was root of x. Bottom is x squared minus 10x plus 25 dx. Since I'm just told to set up, since I'm only told to give, that's it. I don't have to compute. In fact, in this case, I couldn't compute without finding A and B. Alright, so that's it. In this video, we did one example to show you the difference between horizontal and vertical and to see how you can tell from the shape of the region what you should use. In this case, from just looking at the graph, you could draw it and see that you need to switch left at some point, so you need two integrals. But with top and bottom, you don't need two, you need a single one.